Methane burns with 20% excess air. Calculate the adiabatic flame temperature. So for part 1 of this problem, we want to explain how the moles of each species in the feed and the product are determined from the reaction stoichiometry and the given excess of air. So the first thing we know is we are burning methane. Methane is CH4. And when we burn methane, we react it with oxygen, O2, and we get carbon dioxide and water, CO2 and H2O. Now this isn't the full reaction equation, we don't have it balanced yet, but the balancing is pretty easy. We say for each mole of methane that we burn, we use 2 moles of oxygen, and it produces 1 mole of carbon dioxide and 2 moles of water. Just like that. So with this balanced reaction equation, we have the same number of each atom on the reactant side and the same number of each atom on the product side. Now this is the first step to this equation. The next step, we say we're not reacting this equation with just oxygen, where we have air, it's not pure oxygen. And we know that air is 79% nitrogen, N2, and 21% oxygen. So 21% O2. And now if we want to rewrite this equation where we don't just have oxygen, we have oxygen and nitrogen, we simply do the following. We have CH4, our methane, reacts with 2 moles of oxygen, so 2O2, but along with those 2 moles of oxygen, we also have some amount of nitrogen, N2, and that reacts to produce 1 mole of carbon dioxide, so CO2, 2 moles of water, 2H2O, and that same amount of nitrogen that we started with, so some amount of N2. And we can figure out that amount of N2 by looking at the percentages of nitrogen and oxygen in the air. So if we burn 1 mole of oxygen, we use a specific amount of nitrogen that comes with it. And that specific amount is the ratio of nitrogen to oxygen. And in this case with air, it is 79 to 21, the ratio of the amount of nitrogen in the air versus the amount of oxygen in the air. And that is per mole of oxygen that we burn. And in this equation, we're burning 2 moles of oxygen. So we take that amount of nitrogen and we multiply it by 2, just like that. So if we burn 2 moles of oxygen, we are also using up 2 times the ratio of nitrogen to oxygen, or in this case, 79 to 21 moles of nitrogen. And because in our original equation there was no nitrogen, nothing gets used up. So the same amount of nitrogen that we started with, we end up with. So we come over to our product side and we write down that same number, 2 times the ratio, 79 to 21, just like that. So this equation has 0% excess because we don't have any excess oxygen at the end. If we wanted excess like we do in the equation, we have to provide extra air, in this case 20%. So if we add 20% of 2 to our original 2, this is 2.2 moles of oxygen at 20% excess. 20% excess, just like that. Now we can rewrite this equation in terms of that 20% excess. So we still have this 1 mole of CH4, plus the amount of oxygen, which is 20% excess of what we had originally, plus 2.2 oxygen, plus the 20% excess of nitrogen, because that nitrogen is also in the air. So instead of this 2 here, we have a 2.2. 2.2 times the 79 over 21 N2, and that yields, our limiting factor here is our methane, our CH4, So we're only going to produce the amount of products that the CH4 would allow us to do. So in that case, it is 1 mole of carbon dioxide, so CO2, and 2 moles of water, 2H2O. And just like that, we used up 2 moles of oxygen in that reaction. So what we're left with is 2.2, what we started with, minus the 2.0 that we used, and we get 0.2 moles left. So in our product side, we have plus 0.2 oxygen, and then all of the nitrogen that came with it, plus 2.2 times the ratio 79/21 N2. And this equation right here is actually our final reaction equation for what we are doing. We have our 20% excess, we have our air incorporated, and it gives us everything that we need for the next parts of this. So if we want to say the mole in and the mole out for all of our reactants and products, so let's say CH4, O2, CO2, H2O, and N2, just like that. And we can actually write this in a tabular form. So CH4, we started with 1 mole going in and 0 moles coming out. Our O2, we started with 2.2 moles going in and 0.2 moles coming out. And I'm getting all of this from our reaction equation up above. We're going to ignore the amount of carbon dioxide inside the atmosphere, so 0 moles coming in and 1 mole coming out. The same with the water in the atmosphere, 0 moles going in and 2 moles coming out. And then our nitrogen that's within the air is 2.2 times 79/21 moles coming in, and the same thing for the moles coming out. So that is the end of our part 1. And in part 2, we will discuss the energy balance equation and getting the equation for the adiabatic flame temperature.